Welcome back. In this video I'm going to show you two examples of how we can add and subtract fractions where the variable is in the denominator. Now looking at example 3, we've got 4 over a plus 3 over b. As always, our objective is to make a common denominator and then add the two fractions together. So once again we're going to do it by multiplying the two denominators together. Then we're going to multiply the first numerator with the second denominator, and then the second numerator with the first denominator, like so. So going ahead and doing that, we're going to get a times b, that will be ab, all over, and the operation in this one is plus. And our first term in the numerator is going to be 4 times b, so that will become 4b. And our second term in our numerator is going to be 3 times a, which will come out to be 3a. So what we're left with is 4b plus 3a all over ab. Now usually we'd try and simplify this further, but based on what we have, 4b is not divisible by ab, and similarly 3a is not divisible by ab, and we can't add 4b and 3a together because they're not like terms. So this is as far as we can go. Now going down onto example 4, we have 5 over x take 4 over 3x. Now once again our objective is to have a common denominator. Now we can go about this two ways. The first way we can do it is we can multiply the two denominators together. Then we can multiply the numerator of the first one and the denominator of the second. And likewise the second numerator and the first denominator. Now this way would work, but it's going to be a bit cumbersome when we do it. I'll do it anyway just to show you. So we're going to get 3x squared in the denominator, and that's underneath our first term, or I should say our operation is take. Our first term in the numerator is going to be 5 times 3x, which is 15x. And then we're going to get 4 times x, which will be 4x. Collecting like terms in the numerator, 15 take 4 is 11x, all over 3x squared. Now simplifying this out, we have a single x in the numerator and two x's in the denominator. So we're going to cancel the x with the x squared. So what we end up with is 11 over 3x. Now there's a simpler way we can go about doing this. If I copy out the question once again, remember that the only reason we multiply the two denominators together here is because we want to have a common denominator. Now one way we can go about this is we can look at the two denominators and we see in the first one we have x and the second one we have 3x. Now we ask ourselves, what can we do to make them have a common denominator without actually multiplying them together? And one way we can go about doing that is if we go for the first denominator, we can multiply both the upstairs and the downstairs by 3, which in effect is the same as multiplying it by 1, because 3 over 3 is still equal to 1. So we're not actually changing the value of the fraction. Now if I just write out the second fraction to complete the expression, our left-hand side is still in fact equal to our right-hand side. Now multiplying it out, in the denominator 3 times x is 3x, and in the numerator we're going to get 5 times 3, which is 15. Now that's take 4 over 3x. Alright, cool. Now cleaning up the numerator, what we can do is we can rewrite this as 3x over, or 3x under 15 take 4, and that of course is going to come out as 11 over 3x. So we end up getting the exact same answer as we did originally. Notice the difference between the two. In the first one we follow a general rule where we multiply the denominators together and then we cross multiply the numerator with each denominator, and that will get us to the final result, but we have to do a bit of simplification over here along the way to do it. Whereas in the second example of what I've done, you could our objective for this one is we simply want to have a common denominator. So we look at the first one here, and we simply multiply both upstairs and downstairs by 3, and thus we end up with a similar denominator as seen over here. So there's less calculations in the second method. Again, it's up to you which method you want to do and which one you feel more comfortable with. When you become more proficient, you'll probably find that you opt for the second one because it's more direct.